All right. The other type is when you're going to have the logs not adding but subtracting. So when they were adding, we had a log of product. When they're subtracting, we're going to have a log of quotient. So this thing we're going to rewrite, or combine, I should say. Combine using that log A of x minus log A of y is log A x over y. So log A x minus log A y is log A x over y. So with that in mind, let's go ahead and rewrite this. The bases match, they're both log base 3. So instead of a difference of logs, I have a log of product. And the one that's in the front goes on the top, and the second one goes on the bottom. So now I have log of something equals number, so I can rewrite this as an exponential expression, which for the exponential, the base is what I raise to a power, the thing that the log spits out is the power I use, and then what's inside is what the log is equal to. So I get this. Aha! We have not seen one of these in a while. I don't know, this was maybe 2.5? This is a rational equation, which means to solve it, I need to multiply by the denominator and solve what's left, which itself is either going to be linear or quadratic. All right, so let's multiply both sides by denominator. So 3 cubed, by the way, is 27. All right, so I multiply the denominator over. Now it's linear in x. All right, so we get to solve it, you know, like we're used to. So x minus 4, 27x plus 54. Yeah, 54. All right. So let's if we subtract x over, we'll have 27 minus 1 is 26x. We'll also subtract 54, so minus 4 minus 54 is minus 58, and x is negative 58 over 26, which I don't think is an integer. I mean, maybe it is, but I don't think so. No. Well, they both have a factor of 2, right? So divide by 2, we get 4, sorry, 29. So 2 into 5 is 2, with remainder 1. 2 into 8 is 9. 18 is 9. And then 26 divided by 2 is 13. So I get negative 29 over 13. Now, 13 times 2 is 26. So this is, you know, a little bit bigger, well, bigger in absolute value, but a little bit smaller than 2. This should be negative 2.3 or something like that. All right, we do have to check. Now, it doesn't actually matter what this exact number is because negative 29 over 13 minus 4 is still negative, right? If you take a negative and you subtract, you don't somehow end up positive. So this is just more negative. This is not bigger than 0. So I actually cannot use that. So invalid solution. So I did my problem and I ended up with the only answer actually is not allowed to be substituted in. So what's my solution? My solution is that there isn't one. My answer is that there is no solution. So there's no way to make log base 3 of x minus 4 minus log base 3 of x plus 2 equal to 3. If you think of it in terms of graphs, there's nowhere that this function takes on the y value of 3. All right, so if you plug your solution or solutions back in and you end up that both of them have to be thrown out, then there's no solution. And they do have that as a choice on your Hawks. All right. Log base 11 of x minus 1 minus log base 11 of x minus 3 equals 2. So this is the same sort of thing. I have a difference of logs. That means I'm going to have a log of quotient. All right, so log base 11 of x minus 1 over x minus 3 equals 2. All right, now it's log of something equals number, and I can rewrite it. So 11, that's my base, to the second power is x minus 1 over x minus 3. This is rational. Which means I need to multiply by the denominator and simplify. So 11 squared is 121, multiply by denominator. We have 121, x minus 3 equals x minus 1, or 121x minus 363 is x minus 1. Okay, so subtract x, you have 120x, add 363. So I get you 362. So 362 divided by 120. Well, they both have a 2. Let's see if they have anything beyond that. So this is 181 when you divide by 2, and this is 60. 180, I think 180, I feel like 181 is prime. Doesn't have a 5, doesn't have a 3, doesn't have a 2. Have a 12? No. Okay, so 181 over 60 would be simplified. They do ask to, well, first off, we're going to have to check this, right? We will check this in a second, but they also want decimal approximation. So 181 over 60 minus 1. Well, this thing is bigger than 1. Whatever 181 divided by 60 is doesn't really matter. It's bigger than 1. So this overall thing is bigger than 0. And then 181 divided by 60, is that bigger than, oops. Is that bigger than 3? Well, yeah, right? Because 60 times 3 is 180. So this is a little bit bigger than 3. So if you subtract 3, it's still positive. So I do get to have that solution. All right, so your overall solution would be, so the exact is the 181 over 60. The approximate, so they say in Hawks, they want, I think they said 4 decimal places. So 181 divided by 60 in my calculator. So 3.01666666, repeating forever. So when I approximate, I get this, oops, I get this, 3.0167. The exact number that these are doesn't matter. All that matters is if they're positive or not. All right, so this would be your final answer. So with the ones that are subtraction, you're going to usually, but not always, end up with something rational, a rational equation, which means you multiply by denominator and solve what remains.